I haven't read it. Yeah.
If you can hear
Today,
me, if you can hear me through here, I started recording.
since the CCP website is down, I shall be talking on Discord. Is visible? Yeah. Audible? Yeah. Okay. Can I be heard? Okay, good. So now what am I going to say? I had finished grading the exam last week, and yes, Max, I hope you are recording.
I am recording.
Okay, good. I heard you. Okay. So 1A I have graded, and 1A I have sent an announcement about. And there's not much to say. No one was particularly adventurous, and which is not a bad thing. But it's not clear to me whether one has actually understood much more than what is done in the solved exams. And that is not very good. So this is something that you need to understand. I sent 2 Wikipedia articles, one on conic sections and one on quadric surfaces. And you really need to know these shapes and their basic geometric properties and be able to visualize them. The entire class is restricted to these kinds of objects, because if we go to higher degree polynomials, things are going to be very complicated. Okay, so that's where we stand. I also sent 2 videos by Kurtianovsky. I always get his name right, Eugene. So that one is about gradient and partial derivatives. And please watch it, because his videos are very good, even though the language I find a little imprecise. Okay. Now, I have discussed more or less everything that is on exam 1A, 1B. I have no idea whether you understood my very boring lecture, but there is nothing that I can do to make that material more interesting. Because it is a technical result in a way. It is a technical result because it's the chain rule, and the chain rule tells you how to find the derivative of a composite map if you know the derivatives of the 2 components of the composite. So this is given by a formula. The formula looks like this: d of alpha composed with beta is equal to d alpha composed with beta d beta. This is how it is stated in my Calculus 1 notes, and it's really the same formula which is used in Calculus 3. Note that if I evaluate it at a point x, which is in the set of inputs of beta, what I would get is the following. I would get d alpha of, sorry, I have made a mistake. This is not what I meant to write. This is what I meant to write. Okay, so this is So this is also dx of alpha composed with beta. This would be d alpha composed with beta of x, d beta of x, so we have dx alpha composed with beta. This is equal to d alpha of beta of x times d beta of x, which says exactly the same thing as what I wrote down last time. Namely, this is d alpha, sorry, d at the point beta of x of alpha times d at the point x of beta. Okay, so it's the same formula. So you have to find the derivative of the composite at the point x, you have to compute the derivative of beta at the point x. That is a matrix, its representation is a matrix. And then you have to compute the derivative of alpha at beta of x and then multiply these two, which is exactly what we did. Now this matrix last time turned out to be a constant because the map was actually a flat map. So, but it worked out fine. Okay, so this is purely technical. It requires that one actually do the calculation separately. If one is on a normal screen, then one could have everything at once so that I could point to stuff. But since our screen is dynamic, what happened before is going away. So we can't do anything about that. Okay. Does anyone have... Oh, my computer is not being used. Give me a second. I want to talk about the problems on exam. What happened? Give me a second to look at the...
He uses whiteboard. The whiteboard. The native.
The whiteboard on Zoom is very bad.
Yeah, but
Just a moment, let me get
but
one.
it lets you know we can, like, I can, like, let's say you write something.
Yeah.
And you write something over here.
Yeah.
I can just move the whiteboard still and see what you've written here.
Yes, but is the
Well, yeah, I mean, just saying, like, it has some pro.
whatever happened? Home. I don't want home. Oh, this must be this whatever new thingy that did. I want to basically I want to look at the exam so that I can tell you.
I mean, I can give it one. Like,
No, this is
just
okay.
look at it on the iPad.
No. I want to have a exams. Which class is this? 271. 271 exams. I want to look at 1B. Okay, 1B. Let's see. Problem 1A is precisely the kind of thing that we discussed. Compute the derivative at the point A of alpha composed with beta by direct substitution. That means you have to compute alpha composed with beta and find the derivative at the point X, and you will get some sort of a matrix. And then in 1B, you have to compute beta of A, and you have to compute the two derivatives, multiply them, and see that the answers agree. Okay, so this is basically what what I did on during the very boring lecture. That's what you will have to do. Okay, 1C. 1C is to find the derivative of this map phi. Okay?
Yes.
And the map phi is just a sum of powers, but the powers increase. And if I remember correctly, P is different for different people.
Yes.
Yeah, so that's that.
M.
No, it's a P. Phi goes from R to the P to R.
We're talking about 1C, right?
1C, yes.
Oh, it's called M.
It's called M. In my exam, it is called P. No. That is not what I'm talking about. I'm talking about exam 1B.
Oh.
Yeah. Okay.
There.
Yeah. 2A is to find the tangent space to the graph of beta,
Okay.
which I did an example of last week. And 2B, so the tangent space you will get in parametric form, but then from the parametric form, you have to eliminate the parameters and get it in the equational form. And make sure that the number of equations and the number of parameters match up properly. Okay. 2B is to find the normal space. The normal space is essentially the orthogonal complement of the tangent space. I will not work an example out. This you've seen in linear algebra. So you should be able to compute the normal space. Okay. The normal space essentially is is a space consisting of things, all of which are perpendicular to every single thing in the other space. Okay. And you have to find the parametric form and the equational form. Non-parametric means equational. Then 2C is to find the flat approximation to the same map. I have done a problem. I didn't work out normal space, but I did find flat approximation. Okay. 3A, tangent space and normal to S at a particular point. Not terribly difficult. 3B is a bit tricky. Do the coordinate axes intersect S? This is something that you will have to decide for yourself. Coordinate axes are defined by equations. So if they intersect, if you claim that they intersect, you would have to find a point, at least a point. Actually, it says, do any of the coordinate axes intersect S? How many coordinate axes are there in this case? It will depend on P. So if there are P coordinate axes in P dimensions. So you will have to take each in turn, and if it intersects, you would have to find the point of intersection. If it does not intersect, you will have to prove that it doesn't intersect. That means to prove that it doesn't intersect, you basically have to say that if they intersected, the intersection would be a non-empty set. But if there is something in there, then there's a contradiction. So that's the way in which one proves this sort of thing. Is S in a single connected piece? This is a much more tricky question because it is asking you that if you have any 2 points on whatever this is, it's actually a P minus 1 fold. Can you join these 2 points with a curve lying entirely on the P minus 1 fold? Something is connected. If given any 2 points on it, you should be able to join it by some path lying on the fold. Yeah. And if you say it is not connected, you would have to produce 2 points at least, which cannot be joined by a path lying entirely on the thing. So this is not easy, and it will require you to think. Okay, please don't write nonsense down. To try looking at what happens in low dimensions. Well, in 2 dimensions, xy is equal to 1, which would be the curve, right? In 2 dimensions, xy is equal to 1 looks like this. And the coordinate axes do not intersect it, and it is not connected. Because if I were to join this point and this point, this is xy is equal to 1, this is 1, 1, this is minus 1, minus 1, right? If you join the 2, oh, sorry, that doesn't prove that. Why is it not erasing? Okay. Okay. These 2 points cannot be joined by a curve which lies entirely on the one-fold. Why? Because this piece is entirely in the first quadrant and this piece is entirely in the second quadrant. Yeah. And the 2 axes don't intersect it at all. So, but the next example would be in 2 dimensions, in 3 dimensions, and the equation would be xy plus yz plus zx is equal to 3. Oh, this should be xy is equal to 2, not 1. But that doesn't make any difference, because in that case, rather than this would be square root of 2, square root of 2. And this one should be minus the square root of 2 minus the square root of 2. Okay? So now I am not going to tell you what this looks like. In 4 dimensions, it would be wx plus xy plus yz plus zw is equal to 4. So now you find out what happens. Okay, is this clear to everyone? Okay. That's that one, that's 3b. So let's go to 3c and see what that is saying. 3c do all your calculations. Okay, consider exactly my S, my G, my F. Oh, G and F I haven't discussed. So 3b. Yeah. Find a parametric description of a one-fold S. That means a one-parameter thing, a subfold. Find a non-parametric description and find a flat approximation to F at the.
We either have to find something in G which is not part of F.
No.
You have to prove that.
No, you have to. No, just a second. I am still talking about T. Find a flat approximation F to S. So, you see, suppose I have a 2-dimensional object. Suppose I have a 2-dimensional object, like a sphere. A flat approximation is a tangent to the sphere. But suppose I have a curve on the sphere, sort of like this one. It goes all the way around. Then a tangent to this is a line. Okay? So that's what you are being asked to do. And this point, this line is a subset of the tangent to the whole sphere. Okay? So that's what is going on over here. Now, 3C, once you have found G and F, is G included in F? F was the flat approximation. Now, G was the tangent to the one-fold, right? Yeah, G is the flat approximation to T. So, in other words, the curve is on the sphere. Is the tangent to the curve at a particular point included in the tangent to the sphere? That's the meaning of that question. Okay? And find the flat approximation to G at T. So this is what is going on.
Well, it's tangent on a curve with your line, right?
Yes. But you don't, yeah. Tangent to a curve is on a line, yes.
Yeah, but it's tangent to a sphere is a
Plane.
plane.
So the question is, if you take a point on the sphere and the curve is going through that sphere, is the tangent to the sphere at that point, does the tangent to the sphere at that point include the tangent to the curve at that point?
It does.
Well, you will have to prove it. It does, you are saying that because you can imagine the thing. But this may not be in 3 dimensions. So in which case you will have to prove it. You will have to prove that your enemy gives you a point on the tangent to the curve, and that point must satisfy the equation for the...
Yeah, any tangent to basically P dimension shape was a P minus symmetry shape, basically.
You are just making a claim.
No, we're like, that's what it have to prove. That's what I'm trying to say.
Yes, I mean, but this may or may not be easy to establish. This is a question of linear algebra, basically. Okay? So, but it is not entirely clear immediately, because take this example. We take a pointy cone like this. This can be made by considering a part of a circle and then rotating it about the vertical axis. So this point has a tangent which looks like this. But note that the surface is 2-dimensional, but the tangent is 1-dimensional. And there is no 2-dimensional tangent at that point. So one doesn't exist and one exists. So things could be tricky. Okay? So that will depend on the equation and so on. Note that, let me give you then an example of a surface that is connected, we have spent half an hour. Yeah. Suppose I had this. Okay. Do you see what I'm trying to do? This is sort of fattened up axes. That means if you have the axes, there is something that goes like this, something that goes like this, something that goes like this, and they all connect up. Okay?
So it's like a...
There is no, I mean, I don't think you have a name for such an odd.
Like a cylinder that expands when it goes through the... It's like 3 centimeters.
No, it looks like an octopus, actually. The octopus whose tentacles are perpendicular to each other.
No, I'm trying to say, okay, you meant like the 3 cylinders going through each other?
Yeah.
But like instead of like having the same radius, the radius expands slowly as it goes to the center. It's like going...
Well, the radius can't really, yes, in a way that is true, That means the intersections are all made smooth. Yeah, yeah. So yes, the cylinders don't intersect. The cylinders change radius so that when they meet, it's all smooth.
Like, that kind of turns the intersection into a sphere.
No.
It would be, okay, basically it would be a cone.
No. The intersection does not exist as a separate object in this case.
Oh, okay.
We are talking about the surface. So I haven't written up the cylinder problem yet, but I will write it up.
Basically,
That's what
it would be 6 infinite curved chords in a certain intersection of each other.
Do you still want the intersection printed out to the intersection of the 3 cylinders printed out and bring it in?
Yes, that would be wonderful.
You didn't send the prompt yet. You were going to send
He
the.
said he didn't write it out.
I didn't write it up yet, but I was debating whether to give you the plain cylinder or will I make it elliptic cylinders.
Curved cone.
No.
But like 3-way, 6 curved chords.
No, because
No, it's a single surface.
it's gonna be like I said, when I said intersection,
It's not intersecting surface, it is a single surface.
Oh, like it's like you have like this would be a beginning of this is a bad explanation. Like you have a sphere of like clay and you pull out.
Yes. Yeah.
So
Yeah, that's would give you roughly the shape. Yes, yeah. Yeah, if you consider a sphere made of clay, you can sort of pull out stuff, sort of looking like bent cones along each of the axes.
So basically, 4.
there'd be 6. There'd be 6.
There were
6.
surfaces in 3 dimensions?
This is in 3 dimensions.
Yeah,
Yes.
Okay. But they're surfaces, not they're planes. Not,
It's one solid surface.
Yes.
Okay.
Not solid. I mean hollow. We are
one
just-
surface,
yes.
There's with nothing.
Yeah.
It's not solid, but like
Yeah.
if you want to make the shape, you can take the clay and pull it out.
Yeah, in every direction. But so now I will ask you a question. Can you produce such a surface with an equation?
Okay, let me. Like I have an equation. I need to write it to see like how it looks like. Because we can do it in 2 dimensions.
Yes, but that doesn't say anything about 3 dimensions. So but that says nothing. Did you write the program? Did you write the program that is going to give you the graphic? Yeah,
Yes.
Oh, the graph.
yeah,
Well, I mean, I have the equation in my mind. I'm just like putting the.
yeah. But how do you know that the program actually will give you the correct graph? You have no reason to believe that.
Interesting.
That's the most foolish thing that one can do. Yeah, suppose this chat GPT said that this is not a human being, this is a dangerous animal, just kill it. Yeah, what would you do? So it is extremely foolish to trust a program which you haven't written yourself. It is foolish enough to trust one's own program, but to trust someone else's is to give up one's individuality altogether. If the TSA program, when you are trying to enter the United States, claims that you are not a human being, but you are a cat.
To verify my face, I have to go to an engine.
So it's this in general, in the US, people can't calculate at all and pull out a calculator. And this gradual cabbagification has been achieved by letting people use calculators before they should. So if one replaces actual effort of mind, then what calculators did with respect to calculation, ChatGPT will do with respect to reasoning. The end result is not just a cabbage, but an unviable cabbage.
How many much have you used so far?
So excuse the question. If you have equations right up there, I'm not sure if I can think of.
No, but the graphing programs make mistakes because I mean, until very recently, this Mathematica could not draw certain algebraic curves which people had studied and knew about for 200 years. So it's very foolish to rely on these programs. The number of curves is infinite. And we do not have a complete classification of all the kinds of singularities that arise. So to claim that Mathematica is basically what the universe of curves is, it would be just stupid, plain stupid. It's like saying, I can't imagine something, therefore it doesn't exist. Okay. So that's as much as I wanted to say about this. Any questions? It's absolutely worthless.
We just got his opinion of it.
It is completely useless for me. I can live my life very happily without any such
I'm
thing.
not saying as a program itself.
I haven't seen the program, so I can't catch its errors. Ask it that is there grass on the moon? No.
The Bachi question, I'm now going to ask Chad.
So people found like ways to manipulate the program to not obey its own rules.
Oh yeah, no, that's people are doing that day one.
Basically, one thing is like, because it's supposed to be an AI. So one thing people do is it tells a program.
It's A, I agree. Whether it is I or not is an open question.
Yeah.
So
Well, I'm saying
this I find this is sort of like an obsession with death, because rather than trying to cultivate one's own brain and its powers, one is willingly subjecting oneself to the demands of an idiotic machine.
Well, I mean, if everyone just gives up to computers, we would just like de-progress in many ways.
I don't know.
Like instead of progress, we just go back.
Yes, I mean, as I told you, it will be a collection of cabbages and machines.
And then, like at some point, people realize what the hell they did. So
They may not.
Question is grass
On the moon.
There is no grass on the moon. The moon has barren and desolate landscape with no signs of vegetation. The moon has
Well, ask them if they have checked at every point of the moon.
it's gonna see right now. Trust me, I know.
You checked every point on the moon for grass. As an AI language model, I can have the ability to physically observe or explore the moon. Knowledge is based on information that was gathered and documented by humans and their instruments. To date, no evidence of vegetation or grass has been found.
Okay, so tell them, lack of available evidence for the existence of grass, does the lack of available evidence for the existence of grass prove non-existence of grass?
The lack of available
Evidence for the existence of grass on the moon prove the non-existence or establish the non-existence of grass on the moon.
Lack of available proof of the existence of grass.
So available evidence. Yeah, I will. After this, I want to say something. If you ask Chat GPT to do these problems, I expect you will.
It's awful.
Of course, it is awful.
Like,
No, no, but let's see what it says.
The lack of evidence, the lack of available proof of evidence of grass.
No, no, no. Lack of available evidence for the existence of grass. Evidence for the existence of grass on the moon prove the non-existence of grass on the moon.
I wanted to check a few physics with him, so I wrote the question. It provides the right logic. It puts and like makes the right formula, and puts a number in the formula, but it calculates the wrong number.
Yeah.
Which is weird.
What does it say?
So the lack of evidence for existence of grass on the moon proved that there is no grass.
No, no, no. Bring it here. Let me type.
So every single time, like he saw it in the middle of this, I just wanted to like.
Where should I type?
You just read here. You're already typing. So you just
Does the lack of available evidence for existence of grass on the moon prove or establish?
okay. Just say contradict.
Establish the non-establish is spelled wrong. Establish the non-existence of grass on the moon. Enter.
Yeah, enter. Oh, the
Is it
enter is too busy. We have to log back and log back then. Yeah.
But at least you have the question now.
Yeah.
Yeah, we'll throw that back through at some point.
Yeah.
Wait, what happened?
Okay, so coming back, I strongly advise against using ChatGPT. For solving mathematics problems.
Oh, no, it doesn't work.
It will give you total nonsense most of the time. The
Or is it if you call it out, like, hey, you did math wrong, it will then go back and do math correctly, which is the funniest thing.
No, it doesn't.
no, it also gives it also actually gives the false references that it made up.
So yeah, you'll like, I asked it how to solve a system of equations, right? And it said how to solve it correctly, then gave an example, and did the example. Which was the weirdest thing, like, yeah.
No, it just means that the program has lots of holes in it. Okay, now can you have an object which has no okay, let me ask you, put it this way. Is it possible to have a bounded object in 3 dimensions which has a boundary but locally has 2 sides but globally does not have 2 sides?
Wait, what was it?
Okay, does every object in 3 dimensions have to have 2 sides, a top and a bottom?
Every ball in 3 dimensions have to have 2 sides.
Yeah, a 2-dimensional object. Does every surface
Does
need to?
every surface have to have 2 sides?
Yeah.
Well,
Okay, so you don't know. So this is something. Yes. What does it say?
It just said, the summary is, no, it doesn't prove that it isn't there, but, so, yeah, that's what it says. It says the lack of evidence doesn't prove that there's no grass, but what we know about the surface of the moon makes it unlikely that there's grass.
Okay. Now, okay.
well, that's
So a Möbius band is a surface in 3 dimensions which has a boundary, but even though locally there are 2 sides, globally there are not 2 sides. What does that mean? So, yeah, I have to show you maybe a strip by taking my belt. Okay, so you put one twist
Oh, okay, I got it.
and then you have to perform an experiment actually. which is, no, it's a surface in 3 dimensions. Yes, it's a 2-dimensional object. So this is the belt. I put a twist and then yeah. So this surface, if you start going along the edge, you will find that you cover the whole thing twice. And similarly, if you start here, you will, locally there are 2 sides. But an ant crawling from this side will get to the other side. So without jumping.
Object is not like, you could not grasp the existence, like all the dimensions of the object in a 2-dimensional world.
Yes, this is in 2 dimensions. I have not flown out into outer space or something. This object is 2-dimensional. It's a surface which is embedded in 3-dimensional space. It doesn't intersect itself. Locally, it has 2 sides. So I will write Mobius band. Please find a video on YouTube. There's a 3-dimensional version of this also called a Klein bottle. A Klein bottle cannot be embedded in 3 dimensions without self-intersections. A Klein bottle has locally an inside and an outside, but globally it does not. That means
you can make a coin battle by stitching together these strips.
you can, but you should also, there's in Australia, an architect made a Klein bottle house, which you should look at. Okay. Yes, it's in.
So Klein means.
Klein means yeah. Yeah, Klein means small in German.
In German, it means
Small.
Klein. Yeah.
Klein means 9.
Nine.
Yes. Yeah.
It's not named for the name of the.
Yeah,
Yes, the name is after the famous mathematician Felix Klein. Klein bottle. So even in our ordinary space, there are quite strange objects which do not. Okay, so this is a very important point that you should understand. Local properties may not be global. And I remind people of the very famous ancient Indian tale from the Jains, which is a certain philosophical and religious school in India, who have the story of the elephant and blind men. So the blind men wanted to know what an elephant is like. So someone felt the tail and said that it is like a rope. Someone felt the side and said that it is like a wall. Someone felt the leg and said that it was like a pillar. Someone felt the ear and said that it was like a fan. Someone felt the trunk and said that it was like a snake. And someone felt the tusk and said that it was like a sword. The point they want to make is that each statement was locally true. And the statements are not self-contradictory unless you assume a rule of inference which says that from it is locally the case that X, you may conclude it is globally the case that X. So if this rule of inference is not there, the statements are not contradictory. They are just locally true. Similarly, the Earth is locally flat. It does not follow that the Earth is globally flat. However, in the Dark Ages in Europe, people discussed at length if there could be people at the Antipodes. And they said, no, there couldn't be because they would fall off. What they should have realized, and this was already known to the Greeks, that if there were people at the Antipodes, exactly the same argument would work for them, but they are not falling off. Therefore, on the other side, if people were there, they are also not falling off. So this is a very important. Oh no, yeah, the church people didn't have the concept of gravity. And they persecuted Galileo, who told them that they were talking nonsense. The moment dogma of any kind comes into clash with observation, you discard the dogma. Because otherwise you are agreeing to be exploited, which is a very bad thing. Okay, so what else did I want to say? I've said everything that I wanted to say about exams. Now the people on Discord are, how many people are there? Oh, we are the lonely threesome today. Foursome, yes. Okay. I think there's not much else to discuss. Do you have any questions? Oh, that we can discuss later.
I think I meant for this upcoming exam, I don't have any questions. But throughout the weekend.
Okay. Max, then I think we are going to call it a day and shut off. Can you hear me?
Yep. Yeah, I'll end the
Okay.
meeting. Or
So we will
I'll
end the class.
The recording.
Okay.